Sorry, I needed to make this a video lesson, not a live lesson, but it's almost as good, okay? So, I think we've been dealing with sequences, right? But once you've identified arithmetic or geometric or even quadratic now, you know there's like specific formulas, okay? You got to organize that, okay? Because this section, we're also going to have some formulas that are specific to cases, okay? So 9.4, what is the summation notation? Summation notation, I don't know if you know, but it looks like this. Okay, it's a sigma, right? Sigma is the letter S in Greek. Okay, how do you find the sum of finite and infinite sequences? Okay, so there's finite and infinite sequences, and you can actually find a sum for them. It's kind of intriguing. Okay, what is the difference between a series and a sequence? Okay, there's a difference between a series and a sequence, and I'm going to show you what that's a difference too. Sequences, you're right, we've been dealing with it. What do we do with this a sequence? Sequences are like lists of values. Series, on the other hand, is actually what? Series is a summation. Like if we have the sequence 1, 3, 5, 7, etc., if we add them together, then it becomes a series. Okay? It used to be just a sequence, but now it became a series, and that's the difference. All right? So we're going to do that. Okay, let's go through it, okay? I think most of you know the sum of 1 to 100. 1 to 100, when you add it together, what do you get? I mean, how do you get that value that you're thinking of right now? Is there a trick? Or should I go 1 plus 2 plus 3? For example, here's what I'm asking. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus ... forever plus, I don't know, 94 plus 95 plus 96 plus 97 plus 98 plus 99 plus 100, right? I'm going to add up all these numbers. What do I get? But we have no time to actually add them physically, right? So I think a lot of you, I think maybe 50% of you out there, okay, know the trick. And you're right. There is a cool little trick. What's 1 plus 100? Okay, it's 101. You're right. What's 2 plus 99? Oh, it's 101, right? It's 101. What's 3 plus 98? 101. Oh my gosh. What's 4 plus 97? Oh my gosh, it's 101. And this 101 continues. But wait. But how many times does 101 continue? The 101 continues how many times? Well, you're pairing, right? You're pairing. 100 times? No, it's a pair, so 50 times. So you're right. This sum is actually, I'm going to scroll up, 101 times 50, really, which becomes 50-50. The sum is actually 50-50. Now, this trick that you just saw, it produces this formula that's pretty amazing. And that's what we're going to discover this time on this unit, okay? This formula is actually really cool, okay? All right, so we're going to come back to this. This trick will help you identify what to do for a finite series like this one. Why is it finite? I think we all know infinite means what? Infinite means it goes on forever and ever. Finite, it has an end. It has an end, okay? So we're going to see the two cases. Part 1. Let's situate ourselves. Let's get used to the summation notation here. What is each part of the summation notation actually telling us? And in the calculator, I'll show you also when we're back in class, okay? The summation notation, it stands for the sum of terms of the sequence. Here's your sequence. It's a list, therefore it's a sequence, is denoted. Now, you start at 1, a sub 1, until however many you have. So this is actually a finite, right? It ends. You start at 1, you keep going until n. That's what it's saying. Now, another thing I want to tell you about this is this guy right here. What goes in here? This is going to be your, are you ready? Explicit. Always your explicit, baby. Explicit formula goes inside there. Okay, explicit formula. Okay? Lot of different ways. So what is this guy telling me? This guy is simply telling me, okay, you go 1 plus 2, 3 plus 4, ... You add up to a sub k position. Okay, that's what that's saying. This is also saying the same thing. Sum of Okay, it's asking the same thing. Okay, let's practice. Okay, let's practice a little bit. I think some of you guys are familiar with this. Maybe some of you guys aren't. Okay, but I think that it is actually not that obvious. So we're gonna give you some tricky dicky cases. Here we go. Sigma notation. These are all sigma notations, right? And oh, some of them are infinite. Look, oh my gosh, these are infinite. Oh my god. And these are finite, right? Finite, 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 infinite, 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 because we know that the infinity symbol says that, okay? Okay. This guy here, what is it asking you to do? If I asked you to write the actual sequence, would you know how to write the sequence? Do you understand and interpret this notation? You start at 1, 2, 3, 4, until 5. So what is it saying, right? You can use a calculator to compute this too. The sigma notation should be under equation editor, okay? So let's see what this is saying. We're just trying to interpret the summation notation. This is saying 3 times 1. Oh my gosh. Okay, sorry about that. 3 times 1. Dun, dun, dun. 3 times 1 plus 3 times 2. 3 times 3. How many terms? It's going to be about what? It's going to be about 5 terms, right? Not about. It is 5 terms, like that. Okay, that's what that's saying. Okay, so you add that up. Okay, all right, you sum that up and show me what you got. Okay, all right, number 2, let's try number 2. Number 2 says, oh, wait, I have to start at 5 though, and I end at 8. How many terms is that? Think about that. Oh, I hope you were thinking 4, because you start at 5 and you end at 8, so it's inclusive. It's 8 minus 5, but you have to add 1 because it's inclusive. See if you understand what I'm trying to say there, okay? So I'm going to go, this is saying, it's 5 squared plus 6 squared integer increments until 8 squared. That's 4 terms. 8 minus 5 is 3, but you have to add 1 because it's inclusive. Same thing here. 1 to 5 is 4 terms if you subtract 5 and 1, but you have to add 1 because it's inclusive. And whatever that sum is, write it for me, okay? All right. Number 3. Easy peasy. You go from 0 to 12. How many terms is that? Yikes, that's 13, or is that, wait, 12 minus 0 is 0, right? 12 minus 0 is 12, but you have 13 terms, right? So you're going to go calculate. Ready? I'm going to use a different pen. Cosine. You start with 0. Oh, sorry, 0 pi. Okay. If you want, you can just go ahead and multiply. Okay. 0 times pi. I'll write it like this for now. Cosine. What do? You keep adding 1. So it's going to be 1 times pi plus cosine of 2 times pi, dot, dot, dot. This is how we notate if we don't want to write the whole thing out, okay? It's plus cosine of, what? 12 times pi is what you're going to write down. Okay, and see what you get for the sum. Again, have you found it on your program, equation editor on your calculator, the sigma notation? If you click on the calculator sigma notation, what it should show you is something like that, okay? And it's going to give you some empty spaces here, plug in here, and then plug in here. If you don't know, it's okay. I can show you in class. No problem, okay? All right, next, what does it say here? Whoa, infinite, huh? Ooh, okay. Well, you know, on the calculator, it has infinite symbol too, so you can do that too. So again, this simply says sine of n pi, right? What does that mean? It just means you start with 1. 1 times pi plus sine 2 times pi, okay, plus dot, 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 and you put infinite. Yeah, it's a little bit weird. I'm going to put little quotes around that, but just try using a calculator and see what you get. This is an end, okay? See what you get. See if you get a value, all right? All right, same with the other guy, okay? Number 5, same, infinite, and, oh, k equals 1, sorry. K equals 1. My sigma notation is kind of ugly there. Sorry about that. K equals 1, 3, 10 times k. All this will make more sense, much better sense later when we actually do more with it, okay? This one too, you're like, what is happening here? But it just wants you to add continuously. Add in by integers up to k times. Oh, sorry, no, infinite times. About that, infinite, okay? So just use a calculator for these ones and see what happens, okay? We'll discuss when you get your answers and your findings, okay? All right. Let's finish one more thing and then we'll go to the next video, all right? All right, here. Express the series. Why is this a series suddenly, right? Why is this a series? It's a series because it's a sum. You can see the sums, right? These sums. All right, so we're not going to add all this, but we're going to first put into a summation notation. So first thing, Well, let's actually do it this way. Let's write a couple of things that we know already down. What is this series? Or what is this sequence? Is it arithmetic, geometric, neither, quadratic, or what? Okay? You notice it's arithmetic. I see. Well, if it's arithmetic, then we know that it has a common difference, and that's 3. That's easy to recognize, right? So if it's arithmetic, we also know that it has this formula here. Oh, sorry. A sub 1 plus n minus 1, common d, okay? Or a sub 0 plus nd. Remember that formula? Okay? So we can write that formula. So let's actually do that right now. A sub n is equal to, a sub 1 is 2, because this is a sub 1, right? Plus n minus 1, our common difference is 3, so we get 3n minus 3 negative 1. That's our, this is our what? Explicit, baby, or explicit. If you can do it this way, I like that better, okay? I'm just not going to push it right now. Okay, so let's start setting up our sigma notation, okay? Our sigma notation. Ultimately, this is what we want to get to. Where do we start? We always start at 1. Now, if you don't want to use n, you'll find me using k a lot, because k is a good counter, okay? K is a good counter. K is simply, well, you know what? Let's just use 1. N. I don't want you to be confused. N equals 1, okay? Now, okay, my explicit always goes here. Okay. But wait. How do I get that? That should be my end value. Or like this guy here. He's like, what is that? I don't know where to end, right? I don't know where to end. So what do we have to do? We got to do one last step. What is the value of 29th, right? You got to think about that. Okay. So what do you have to do? A sub n is equal to 3. You don't know, right? You don't know this. But what do you know of this formula here? I guess that's what I'm asking. What do you know of this formula here about this? You know that 29 is 3n minus 1. So you got to kind of calculate the n. So what do you get for n? N is equal to 10, and 10 goes here. This is the tricky part, so I'm going to put stars around it, because that's the tricky dicky part. So summation notation for this is this here. Okay? Writing a summation notation is pretty tricky. So that means this has 10 terms, because you went from a sub 1 to a sub 10. So I could ask you, hey, what term is this? That's a good question on the test, because you have to go through all this in order for you to recognize that it's a 29th, or 29 is a sub 10. Okay? Tricky. How about here? Okay? I'll do the same thing. Identify whether it's A, G, and Q plus. And you're like, 149. This is a sub 1, of course, a sub 2, a sub 3. And how is it being used? This is also a series. You're right. This is neither. This is neither. That means you got to think of a formula for this explicit, right? Well, it looks pretty easy. It's going to be, oh, it's right here. It's n plus 1 squared. N plus 1 squared. Wait a minute. N plus 1 squared. Does that work? Let's try, okay? Interesting. Wait a minute. Wait, n plus 1 squared? Is this infinite then? Because it doesn't seem like it has a, right? It doesn't have like this, 29, a constant value, right? So you're like, that's a little bit weird. Okay, but this is our explicit for sure. Okay? And we start with 1. Do we start with 1? But this is a sub 1, and this is 1. Okay, this one's a little bit weird, so let's actually try. We're going to do a summation notation. Let's just always just start with 1, okay? Let's just start with 1, okay? And we know that our explicit goes here. But remember, whatever I start with, I plug in here, it needs to give me this value. Is that going to give me this value? If I plug in 1, I get 1 plus 1 is 2. 2 squared is 4. It gives me this guy here. So how do I adjust this? I know you're thinking, okay? I know some of you guys got it already. Were you thinking maybe n should start at 0? Because it sure could. Let's try, okay? 0, I get, what do I get? 0, I get 1 square. 1, the next number is 1. 1 is 1 plus 1 square, which is 4. Tricky dicky, and I'll put an infinity here because you know that this continues forever. That's why there's no actual value there. Okay, remember, we're focusing here, okay? What we're focusing on is that it's an infinite, okay? Can you go back and write into a summation notation? So if you could understand the summation notation, then that's the takeaway from this section, okay? All right, watch the next video. We're going to move on. Make sure you ask any questions, okay? Bye.